Well, let me push on that. I'm guessing you must have some engagements where there may be a presumption that a deep sort of SME team in security would be able to do the test generation, but maybe that's not right, man. I mean, you guys, you really don't have to be super hackers to take a spec and build the best possible data for cyber application.
You're correct.
Right?
A good example of that is we did a project, and I'll let Joshua will speak more, I think, to the details of this. But we did a project for DARPA called the Adams Project.
Oh wow!
Where we were, the request was to generate simulated synthetic data for to aid the development of the researchers.
Yeah.
And the folks some of the competitors that were vying for the same work were expert in the area of threat detection.
Yeah, whatever the PII was doing,
correct.
They live in that
and
area.
I think intuitively that might make sense.
Yeah.
But we came in and really established that this ability to generate data is a discipline unto itself. And it turns out we started as competitors, but we ended up working hand in hand with that threat detection expert.
Are you the house band at DARPA now for this kind of thing? Seems like you should be.
We'd like to be, but
well, if there's some people from DARPA watching, I mean, this seems like a pretty nice engagement. You worked on that project?
I did.
I bet that was a fun one.
It was, yeah. So the Adams program, had its unfortunate genesis in the Fort Hood shooting, at which point DARPA decided that they would fund research in tools to aid analysts in better detecting insider threat activity. And so the Adams program itself had several phases. The first one was a sort of white space public phase in which they invited the research community to come and participate in certain challenges. They set up 4 challenges for which DARPA had CERT, the organization at CMU, to supply data sets which would represent the challenge.
Yeah.
And all the researchers would come together and work on it and compete and get down selected for later phases of the project. And CERT had us creating the data sets. And so for that we had to create a model to generate the data sets. And we took a similar approach from the standpoint that first, what you need is to figure out a plausible pattern of activity and events that happen in cyberspace, and then color it with the artifacts that are thrown off by that activity. Since it's human activity, and humans are social, the basis of it would be a social network, and the other component would be the behavioral model of individuals. And so our model combined those 2 aspects. It had a social network model, which takes for any size population, allows you to composite the effects of any number of relationship functions that you want to impose in that population, like we live near each other, or we have similar affinities or similar interests, or we work in the same group, or we have the same shopping patterns, or we play the same games online. Those functions were all composited into a network, which would then provide would show topic propagation between people. I've got something an affinity, and it's got a certain strength, and the more I interact with you, the more likely you are to acquire that topic as well, and watch those topics migrate and change the social network over time. And then the other component would be, well, what do people do? They have impulses to do things like email or read email or surf the web or do some project-related work or send files, that sort of stuff. And so we had a component in the model which says, people know how to do all these different things, and when you study the statistics for a population, you find that the base rates of these activities are that on average, somebody might send 10 pieces of email between 1 and 2 o'clock in the afternoon or something like that. And so you would take these base rates, they would influence the rate at which impulses occur, and the impulses would get translated into events, and with a natural filter that the laws of physics have to be preserved. So I might have an impulse to phone somebody right now and send email right now and pass through that door or print a document right now. But the laws of physics say they can't all happen at once. So something has to select and be the gatekeeper there, and that would be psychological factors or the strength of the affinity or the impulse. And that was all wrapped up in one part of the model. And we had this model for an entire population so that at any point a person would say, well, it's time for me to send email. And okay, I'm going to send email. Who am I going to send it to? I'll go to the social network and see who I'm most likely to send it to. And what is the email topic about? What am I going to talk about? I'll go to the social network affinity propagation component and determine and see what the topic at that moment is. What's the which one would have the most strength. And so that was the basic core of the model, which would produce sort of the massive haystack of benign activity that goes within an organization. And then we had what we call the needles, the impulses to do malevolent things, and when it was time for that would have an influencing function on the impulses, and the topics that would be involved. And so I might say, now it's time for me to exfiltrate files from my organization, or now it might be time for me to collaborate with a couple other people towards some given end. And so those behaviors would get expressed in the time sequence of activities, and then the final step would be just to put the artifacts on them. So I've sent email to these 3 people with this CC, with this attachment, but what is the content of the email? And that would come from a separate model.